Okay, so now let us start partial differential equation. See what I told you, if it is a dy by dx, in y is the dependent variable. So here y is dependent variable and x is independent variable. Okay, so here if in the equation I told you ordinary differential equation, so here number of independent variable is only one. But here in PDE, partial differential equation, number of independent variables are more than one. So this is the definition of potential differential equation, that here number of independent variables will be more. Why it is dependent variable? Because y is a function of x, so y depend on x, but x is independent. So how we can write? Suppose psi, if we take a function psi, for example psi, so psi function depend upon x, y, z and t. So these all are independent variables, but psi is dependent variable. Okay, so any equation containing x, y, yz or xt or zt or yt means more than one independent variable. So you can say any differential equation containing all can be there or any two can be there, but more than one it should be. Any differential equation containing more than one independent variable is known as partial differential equation. Okay, so this is the definition, and like this you can understand. Now you can see the examples. Number one, in quantum mechanics, Schrodinger wave equation. What is that? Can anybody tell?
Minus h cross square by 2m del square by del x square.
Minus h cross square by 2m del square psi by del x square
plus v psi equal to I h cross del by del t.
Okay, so this equation is containing x and t, or you can take, if it is in 1D only, but x and with time. Okay, if it is in 2D, then x and y will be there. If it is in 3D, then x, y, z all will be there. Okay, so Schrodinger wave equation will have so many variety or so many types. Okay, it depend on where you are using it. So that equation comes under partial differential equation. Note on this. psi is also here.
Then, sir.
Okay, so next example is the Laplace equation. So in Laplace equation, that equation is del 2 psi over del x square plus del 2 psi over del y square is equal to 0. So this is in 2D and it is also having 1 and 2. So these are two independent variables. Okay, so these are the example of potential differential equation. Now we will come to directly on method how to solve such problems. So what we do here, first we have to convert potential differential equation into ordinary differential equation. By variable separable method. And then solve the problem. Okay, ordinary differential equation, first order, second order, both we have done. Okay, so you have to convert potential differential equation into ordinary differential equation, so that we have to learn how to convert. So that is the main thing. So simply potential differential equation by using the variable separable, you will convert PDE into ordinary differential equation and then solve it. So this is a simple procedure. Okay, but you have to learn how to do that. That is important. Okay, so here before variable separable, we have to do some extra method. This is the step you have to follow. If a function psi xy, suppose, is dependent variable on two independent variable, or like this you can write, if a function psi is dependent on two independent variable x and y, then we can write this function as a product of xx and yy. So here x is the function of x, y is the function of y. Means x is function of purely x only, y is function of purely y only. Okay, here psi is depending upon x and y. So it is depending upon two independent variables. But x is depending only on one independent variable x. Y is depending on independent variable y, that is only one. So capital X and capital Y separately can make the ODE if you have the variable separable. Understood? So like this trick we will apply. So first of all, this psi xy can be written as product of two independent variable x and y which are depending on only one independent variable. Note down this. Or more clear you can make it. So we can write this function as a product of x and y which are x and y. So like this you can write, that is only function of x and only function of y respectively. So now it is more clear. So why we want such function? Because their function will constitute the ODE. We are going towards that. So once you write this in term of that, then you can have variable separable and you can find out the ODE, and ODE simply can be solved. Note down this. Done?
Yes, sir.
So psi xy will be xx into yy. Okay. So x will make one different ODE, y will make different ODE. So from here I can get two ODE, two ordinary differential equation will be made. Okay, separately both can be solved, and after that you put here, then you will find the solution psi. Okay, so that is our planning here. If another function suppose psi depending on r theta phi, so then with same way what we can do, we can have psi r theta phi can be written as separate function of r into separate function of theta into separate function of psi. So that can be written as product of rr into theta theta into phi phi. And this everything we have done in the quantum mechanics. Okay. So this is from partial differential equation only. So here 3 ODE can be made or will be made. And 3 ODE will be solved, then we. So all the Schrodinger equation are solved like this only. So that's why we have to learn it very well. Now, so directly let us take one question. With that you will understand more. The question is, solve del u or del x equal to 2 del u or del t plus u. So this is suppose equation 1. Here u is a function of x and t. This is clear from this equation. Okay. X and t are two independent variables. Okay, so first thing is that, and here some boundary condition is also given. Condition is u x0 is equal to 6 e to the power minus 3x. So it means x0 means here this condition is at t equal to 0. This is the meaning of that. Okay, so note down this. So finally what we want means you have to find uxt. This is our question here. Solution of that means you have to find out u, and u is function of x and t. Okay, so this is very easy, only once you have to practice it. Okay, so what I told, just we have to do variable separable, but first we have to do how to write u. So we can write uxt. Uxt is our function. It can be written in the product form. So what can be the product? Xx. Xx is pure function of x. This is capital X, this is small x. Dot capital T T. We can write this in the form of product. Now this is pure function of x, this is pure function of t. They will give you 2 ODE. That is our main motto. Okay. Or it can be written in the form xt. We know that x is function of x, t is function of t. So you can write u equal to xt. So this replacement you can do in equation 1. So from equation 1, you put it here, del u by del x. Now because this is the partial derivative, so here t will be taken as constant. So it will become t del x by del x. Understood? That will be equal to twice into del u by del t. Now u is xt. Once you put it, so here x will be considered as constant because it is the function of t. So x into del t by del small t, and plus u is xt. So this has become my equation. Okay, so carefully you have to do such type of problem. Now to get the variable separable. Okay, so this replacement is over. Now second step is variable separable. So in variable separable, so first of all what you can do, divide whole equation by xt. So what will happen here, t will be cut, so it will become 1 by x del x by del x. So it is variable separable now. Again here, if you divide by xt, so x to x will cut and only t will be remaining. So it will be 2 by t del t by del t, and plus it will be 1. Now tell me, on left hand side pure x is there, on right hand side pure t is there. So it is variable separable. Okay. Now because this is independent of this, understood? This is independent of this and both are equal. This can be only possible because no variable, now variable connection is not there. T is a separate function, x is a separate function, and both are equal. This is possible only when it is equal to some constant. Okay. So here you can write this is only function of, because function x do not have any relation with function t. They are separate, and because both the things are equal, so they will be definitely equal to some constant. This is only function of x. This is only function of t and independent also. And this is also independent. Okay, so both the things gives. So by this thing we can have, once both are independent, this is also independent, this is also independent, and both are equal, so this gives that. So it is only possible when equal to some constant. So this constant we can take as per our choice. Okay, note down this. In first question you have to learn very well, so then from second question it will be a good practice. Suppose I am taking here some constant lambda. Okay, so now tell me, this thing I can take equal to lambda, and this thing also I can take equal to lambda separately. So now two equations have become now. Okay, hence we can have two ODE, two ordinary differential equation we can have. How? First will be 1 by x dx by dx, sorry, del x by del x is equal to lambda. So this is one equation. Now one more thing I want to tell you, if in the equation only one independent variable is there, so it means it is ODE, and in ODE this symbol will be changed, so this will be directly d. So I can write 1 by x dx by dx is equal to lambda. Okay, so here this is my equation number 2. Again one more equation I will get from here, second ODE, 2 by t into, in place of del t by del t I can write dt by dt plus 1 is equal to lambda. So this is equation number 3. So these are the two ODE. These equations we have to solve and we will get the answer. Okay, so this is our procedure. Now here from equation 2, one by x dx by dx. So this x is now dependent variable because it is depending upon x, small x, and here x is independent variable. It is working like a y, it is working like a x. Okay, so now here also we can have variable separable because this is equal to lambda, so this implies dx by capital X will be equal to lambda into small dx. So now integrating on both sides, this will be ln capital X, this will be lambda x plus c. Okay, now I told you this c I can adjust, just constant should be there, I can adjust it anytime. Sometime I can take it e to the power c, sometime I can take it ln c, whatever. Okay, so just you have to mind it that this is a constant, and as per my choice I can have this anytime. It can change the forms. So here mainly my motto is to find out this capital X. So taking antilog on both sides, so capital X will be e to the power lambda x. Okay, but with that I have to keep that constant, so that constant can change the form. Suppose it has become now a, so this is my value of x. Understood? Note down this. Miss, you can understand here once only I'm telling you. X will be e to the power lambda x plus c. So how you can write it? E to the power lambda x into e to the power c. So this e to the power c, because it is also a constant, so I can say that this is another constant a. So you am writing that. Okay, so any time in any type means constant should be there. That's it. That's I'm writing. Note down this. Done.
Done, sir.
Okay. Now we have to solve equation number 3. So from equation 3, you can do what a variable separable. It will be 2 by t dt by dt is equal to lambda minus 1. So this implies 2 dt by t will be equal to lambda minus 1 into dt. So we can integrate it like this. So again it will be 2 ln t will be equal to lambda minus 1 into t and plus some constant, suppose it is c1. Okay, now here also it will be this 2 will go here, it will become by 2. So take antilog of this, so t will be e to the power lambda minus 1 by 2 into small t and plus plus c1. So that will be e to the power c1. That e to the power c1 I can put some another constant b. Okay, here b is e to the power c1. Like this you can understand. Okay, so this is your b. Now hence now your solution is u xt will be equal to A into B into e to the power lambda x, this value, e to the power lambda x, into e to the power lambda minus 1 divided by 2 into t. Okay, so don't leave these two constant. So multiplication of that will be some other constant. Suppose it is k, that is also a constant only. E to the power lambda x into e to the power lambda minus 1 by 2 into t, that is uxt. So I have only one constant, that is k now. This is my equation. Now put the boundary condition. From boundary condition, when the boundary condition is what? At t is equal to 0, ux0 will be equal to, so any one of them can be 0 or some limit. Understood? So that we can put as a limit, and rest will be x will be as such only. So it will become k into e to the power lambda x will be as such. Only t you have to make 0 now. So that will be e to the power 0. Okay, and what is the value of ux0? They have given this ux0 value is 6 into e to the power minus 3x, and that will be equal to k into e to the power lambda x. Okay, so now on both the side we can compare the coefficients. So k will be equal to 6 and lambda will be equal to minus 3. So this implies comparing on both sides, k is equal to 6 and lambda equal to minus 3. So that those value we will put here and we will get uxt. Note down this. So uxt will become, here only we can write k is 6 into e to the power lambda x into e to the power lambda minus 1. Sorry, in place of lambda we have to write minus 3 now. So it will be minus 3x. It will be minus 3 minus 1 minus 4 by 2 minus 2t. That is the answer. Okay, understood this. So now you go through this question quickly and understand what is the procedure we have done. So we will do the next question now. So next question I am taking one-dimensional undamped wave equation. Undamped means no friction is there. Okay, so free motion is there if you are doing it. Suppose it can be created, such type of motion, such type of wave can be created if these are two ends. These two ends are fixed. They are fixed and they are not moving. So with those, if you tie a string, this is a string wire. With tight ends. These ends are tight, they are not moving. Okay, so what you can do here, you can give some displacement. Give some displacement. If you take it down and leave it, so it will make some waves like this. So these waves, like this, it will make the waves. Okay, but these waves will be such that they will depend upon two things. Suppose I am looking the displacement. Suppose this is the displacement. How much is the displacement from the mean position that I am looking here? That is known as displacement. And that displacement can be written in the form of two functions. One, it will depend upon distance also. Second, it will depend upon time also. With time also this is changing, because at next time this displacement is less, at this time it is 0, at this time again it is negative, again it is higher, again it is negative, 0, again it is highest, positive side, like this. So this displacement is changing. Suppose this displacement is denoted by u. Okay, so u can be a function of position. This is the position. So it with position also, if I am checking that at x1 position, x2 position, x3 position, so this is changing. With time also, as the time passes, then also it is changing. So it means here displacement is the function of two variable. So like this question can be created in the exam. So suppose this value is x equal to 0 and this value is x equal to L. Okay, so here as we give, or like this you can say, as we give some displacement to string, it starts oscillating. So this is the scenario. So in that scenario, what can be the equation? So one more thing you can write, that displacement is changing with time as well as position. Here displacement u xt is changing. Actually displacement of any point if you check on this string, so that is changing with, means that is changing the displacement every time, and with position also. If you are changing the point position, then also it is changing. If you are changing the time with the same point, same position, then also it is changing. So here displacement is changing with position x and time t. So this is the scenario here. So this displacement can be governed by some equation. Hence by a wave equation, because it is making a wave. And now tell me, what is a wave equation? In EMT I taught you. Anybody remembering wave equation? Del 2u, there we have used v, but here you can use u. Del 2u means, suppose this is a function which is making a wave. We have used del 2f over del x square will be equal to 1 by c square into del 2f over del t square. Remembering this equation? Okay, so this is same wave equation. In place of function f, here function is u. So del 2u by del x square will be equal to 1 by c square into del 2u by del t square. So this is the wave equation. Okay, so this can be converted as, here I will tell you one more thing. If differentiation is del f by del x, partial differentiation, so that can be written as simply with that f in the subscript you write small x. That is the meaning of del f by del x. If it is del f by del t, so we can write it ft. Okay, if it is del 2f by del x square, so then that can be written as f xx. 2 times you write x, so it means it is 2 time differentiation, 2 time partial differentiation. If it is del 2f by del t square, so that will be written ftt. So these symbol you must remember, and you can note down them separately. These are the symbols we will utilize. So here, if I use this symbol, so this equation can also be written as c square into u xx will be equal to u tt. So this is the equation. Whether this is the equation, so in some books it will be written like this also. So both the things we should know. So this is double derivative of with respect to x. Double partial derivative with respect to t. This is same double partial derivative with respect to x. This one. Okay, note down this.
Then, sir.
Okay, so here now you have to solve this equation also. Okay, so before that you can check whether this equation is okay or not. You can check the dimension. So dimension, how to check? This is u dimension will be u, x square dimension is l square will be equal to 1 by now c square. C square dimension is, c is the velocity, velocity of light. Okay, so c dimension will be l t minus 1 whole square of that, so it will be l2 t minus 2 into, again it is del 2u by del t square na, by t square. So this t square to t square cancel, u to u cancel, l square to l square. So this is satisfying. Okay, so like this it is dimensional wise be, it is okay. Okay, so now our problem is now to solve wave equation. C square u double x equal to u double t. So this equation you have to solve. If you are not comfortable in this, so you can write in this form also. C square del 2u or del x square will be equal to del 2u by del t square. Suppose this is equation number 1. Now here what you have to do, variable separable method we will apply, but before that u can be written in the product form of function of x and function of t. Put u xt is equal to xx into tt. Okay. Now simply it is u equal to xt. So this you have to put in this equation. So what we will get? C square into del to u or del x square. So double differentiation, because this is the partial differentiation. So t will be constant here. So t into del to x by del x square. That will be equal to del to u by del t square. So x will be common here. Del to t by del t square. So like this you can do. Okay. Now you can do, because I told you, first of all you have to do the variable separable, and for that what we have to do? Divide by this xt. So divide the whole equation by xt. So now it will become c square by x into del 2x by del x square equal to x divided by xt. It will be 1 by t del 2t by del t square. Now I told you one more thing. If differentiation is with respect to x, that is known as x dash dash. If differentiation is with respect to t, that is known as dot dot. So in that form also you can find in some books. So that also you must know. Means this can be written as x dash dash double dash. So x double dash means double differentiation with respect to x. That will be equal to 1 by t double dot. Okay. So in that form also you will find written somewhere. Note down this. But we will solve the problem by using this only.
Done, sir.
Okay, so one more thing I told you, that because this is only function of x, this is only function of t, and both are equal, they are independent and equal, so that's why they can be put with some constant. So here, because constant is of my choice, so I can take, because everything is in double derivative, so I can take the constant also in a square. First of all, that thing. Now that I am taking minus sign, with minus sign. In such question, if I take it minus sign, because ODE will become, that minus sign will go to the left, ODE will become plus sign, and with that we will get d square plus lambda square equal to 0. That will be my ODE equation. Okay, and roots of that will be plus minus lambda I. And with that I will get the answer in cos and sine. And because this is a wave, and wave always should be in cos and sine, so that's why I am taking, purposely I am taking this minus lambda square. This type of equation, if it is a wave equation, because you want the answer in sine cos, so that's why purposely, deliberately you can take it lambda square. So c square by x del 2x by del x square equal to 1 by t del 2t by del t square equal to minus of lambda. Just minus sign I am taking as per my choice. Otherwise, because this is in double derivative, so just take it here also you take square power 2. So now separately you can get, so separately we get 2 ODE. Number one is c square by x del 2x by del x square is equal to minus lambda square, or you can say c square by x into del 2x by del x square plus lambda square is equal to 0. So this is my equation number 2. Again, second equation I will get 1 by t del 2t by del t square is equal to minus lambda square. So from here also I will get 1 by t del 2t by del square plus lambda square equal to 0. Okay. Further I can solve this. Further I can make this like this, because I want here coefficient 1, so it will become del 2x by del x square plus x by c square into lambda square, or you can write it like this, lambda square by c square into x, lambda square by c square into x, that is equal to 0. Okay, this is homogeneous equation, homogeneous second order differential equation, and from here I can get del 2t by del t square plus lambda square into t is equal to 0. So here this is my equation number 3. Now from equation 2 we can solve that. So that equation is d square plus lambda square by c square into x is equal to 0. So this is my FD equation. This is my FD equation. So auxiliary equation I will get. This is your FD. Okay. So here auxiliary equation is d square equals to minus lambda square by c square. So d will be plus minus I lambda by c. Okay. So you can say that this is 0 plus I lambda by c. You can write it like this. So these are the two roots. Okay. For two roots which are imaginary or complex number, so then you can get the answer for that, means solution of that. Okay. Note down this.
Sir.
So from here I can get the value of x. X will be e to the power 0, a, this is constant, cos beta x, beta is lambda by c, plus b sine lambda by c x. So like this, you can write the solution of this. So this is finally a cos lambda by c x plus b sine lambda by c x. So this is the value of x. Okay. Now next is your t portion. Okay. So from equation 3, that equation is t del means d square plus lambda square into t equal to 0. Okay, so this will work here fd. So auxiliary equation will be d square plus lambda square equal to 0. So d equals to plus minus I lambda. So simply hence, so t solution will be here also because e to the power 0. So now in place of a I can take a dash, that is also a constant, a dash into cos lambda t plus b dash into sin lambda t, because here variable is small t, here variable was small x. So this is the t. Now t and x both are found. So your solution will be u will be or uxt multiplication of both x into t. So it will be a cos lambda by c into x plus b sin lambda by c into x dot a dash cos lambda t plus b dash sin lambda t. So like this you can write, this is the simple multiplication of that. Okay, so this is your final answer. Now in this question in the exam they can give you some boundary condition. Definitely if you want to find out a dash b dash, understood? So that question also we will create. In the same question we will give the boundary condition and how we will solve that. So that also we have to learn. Note down this. So now because here a dash b dash 4 constant are there. So to get 4 constant value we need 4 boundary conditions. To get values of 4 constants we need 4 boundary conditions. Okay, sometimes they can give 2 only. So then our question will have, means our answer will have 2 constant will be remaining.
Sir.
Okay. Now, suppose 2 boundary conditions number 1, u0 t is equal to 0. So what is the meaning of that? At x equal to 0, function value will be 0. And second is that u L t is equal to 0. What is the meaning of that? At x equal to L, function is again 0. Now check my original question. Actually, if these conditions are not given, then also you can take. Now tell me, at x equal to 0, this is my point. At x is equal to 0, definitely this displacement will go to 0. At x equal to 0, u 0t will be 0 only, because this is the fixed end, and at the fixed end it will be always 0 displacement. At this fixed end also it is always 0. So at x equal to L also your u Lt will be 0. So these conditions if are have not been given in the question, so you can always take. Okay, so this type of a skill you should have, because it is visible here. The displacement is 0 at x equal to L. Displacement is 0 at x equal to 0. X equal to 0. Yes. Okay. So I am taking the same boundary condition. If it is not given, then also it is okay. Okay. So applying this equation here, this is my equation number 4. So from equation 4 for condition 1, at x equal to 0, ux0 will be equal to, put it here, x equal to 0. So sine 0 will be 0, only a will be left. Okay. Okay, I can do one thing. I can apply this condition not in equation 4, but if you apply it in equation number 2 and 3. In equation, solution of this, actually you can put this equation 4, you can put this equation 5, and this equation 6. So now in 4 you can put it, so that one constant you will get. In 4, if you apply x equal to 0, so this term will be 0, only this term is left. So it is cos lambda x, lambda by c into x, so cos 0. So cos 0 is 1, so a is equal to x. So what you can write, ux0, first of all, ux0 is what? Xx into tt. Okay, so sorry, it is 0t na. So x0 into tt. Now tell me, what is this condition? This is equal to 0. So complete thing is equal to 0. Now tt is not a 0. So this implies x0 is equal to 0. Okay. So now this is your equation number 4. In equation number 4, you put x equal to 0. Here you put x equal to 0, so it will be a will be equal to x0, or a is equal to 0. So this will give you A into 1 plus B into 0 is equal to 0, and this implies A is equal to 0. Understood this? Means U0t can be equal to x0 into tt. That is equal to 0 as per boundary condition. Now tt cannot be 0. So that's why x0 only will be 0. So x0 is 0 means now from equation 4. So here you can write this thing. From equation 4. You remove it from here. From equation 4 you can write here. So here you apply at x equal to 0. So then you will get a into 1 means a into cos 0, that is 1, plus b into 0 equal to 0. So a is 0. Okay. So a can be removed now. Now similarly, but here you can write for boundary condition 1. Okay. Now we are taking boundary condition 2. So for boundary condition 2, what you can do? U L T will be equal to 0. That is also 0. Now U L T I can write as XL into XT. That is also equal to 0. Okay. Now this implies XL equal to 0 because XT cannot be 0. So XL can be 0. So XL value will be again, because this is the see here from equation 4 again. You put x equal to L here and x equal to L here, but here you put this is already 0. Okay. So B into sine lambda by C into L will be equal to 0 because XL is 0. XL is 0 means A is already 0. So first term already 0. So B into sine lambda L by C will be equal to 0. So this implies now here B cannot be 0. Otherwise your total x function will be 0. So here sine lambda L by C is equal to 0. And that can be written as sine n pi. So by comparing on both sides, lambda L by C will be n pi. So it means lambda will be n pi C by L. So that replacement also we can do. So by these boundary condition, only this much we can find out. So hence, from equation 6, uxt will be in the 6. See what I will do. This is my 6. First of all, this term will go to 0 because a is 0. So only this term is left. In that, lambda will be replaced. Lambda value will be n pi by L. It is lambda square by C square. X lambda square by c square. C square lambda square. One change you can do, that is small change. Actually, that is also okay. What we have done, that is okay. No problem in that. But as per book, I want to change it. See here, this is our equation now. So in that equation, what change I am doing? This c square, they have taken in place of with x, they have taken this with t. So it means that equation will become 1 by x del 2x by del x square equal to 1 by c into 1 by t del 2t by del t square, and that will be equal to minus of lambda square. Is there any problem in this? So we can do it. Okay. So now here c square will not be there. It will be 1 by x this much, 1 by x this much. That change you can do so that you will not be confused if you see the books. Otherwise that is also okay. C is constant, anywhere you can take it, and here you have to take it. C square. Okay. And that c square will go with lambda square if you are not taking here. It will be c square lambda square. Okay. So c square lambda square. So here, if you are solving the equation number 2, so here c square is not, c square is not here. This c square you can remove. This c also you can remove. Okay. So c will not be here. Now from equation 3, here with lambda c square is there. So it will be lambda c. So answer also will be lambda ct, lambda ct. So at the final answer, this will be like this, and it is c here. C you can write here. Okay. So when you are applying this, so here c will not be there. So lambda will be n pi by L. So now from equation 6, this will be A cos, sorry, check here. Here this term is totally 0. So it will be remaining B sine. In place of lambda, I will write n pi by L into x. Okay. And this term will be complete. So it is B into sine n pi by Lx, b into sine n pi x by L. Understood? So this is from first portion, and second portion is complete. A dash cos c n pi t by L plus b dash sine c n pi t by L. Okay. Now what I can do here, actually n values are so many. Here n is equal to 0, 1, 2, 3, 4, dot, 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 up to infinity. So it will give you an infinity series. Understood? So what you can do, because this b is also a constant, so this can be multiplied with a dash, so that will give you a different constant. This b will be multiplied with b dash, that will give you a different constant. So ultimately two constant only will be remaining here. So you can put a dash as an, b dash equal to bn, and why this is a constant, simple, a and b, and it is depending upon n, means this constant can change if we are changing the n value, and because it will give you a series, so that series, for that series I can put summation also. So this answer will be, uxt will be summation n can be 0 to infinity. This a dash I am replacing an, cos c n pi t by L plus bn sin c n pi t by L into this first term. So first term will come sin n pi x by L. So this is the final answer. Okay. So exactly this much big questions will not be coming in the exam. I will tell you the short trick to solve such type of problem. Okay. So tomorrow we will discuss that. So quickly you can solve the problems, but we are learning what is the complete method, complete theory, because in quantum mechanics, in EMT, you have seen that partial differential equation are used. In wave equation we are solving the problem. In Fourier also we are solving the problem. Okay, they are from partial differential equation. So note down this.